All right, welcome everyone. Today we're doing something a little different. We're going for a really deep technical dive into a modular blockchain project. We're going to pop the hood, look right at the source code, and figure out what makes this kind of innovative tech actually tick.
So let's just get right to it. The big question in the space right now, is the future of blockchain monolithic or modular? I mean, are we talking about a single, all-in-one system or a flexible set of specialized components? The architecture we're digging into today offers a pretty compelling answer.
So what's the actual difference here? Well, think of a monolithic blockchain on the left like a statue carved from a single massive block of stone. Every function, consensus, execution, data, it's all locked in together. It's powerful, sure, but it's rigid. Now look at the modular approach on the right. This is more like a high-tech Lego kit. Each piece has a specific job and you can swap out or upgrade one piece without having to tear the whole thing down. This flexibility is the key to solving one of blockchain's biggest hurdles, scalability. Okay, here's our roadmap for today. We're going to unpack the core concept, dissect the architecture piece by piece, look at the heart of the system, the database. Then we'll head into the engine room to see how mining works, understand the brain behind the smart contracts, and finally, we'll talk about the incredible potential of this whole approach. All right, let's dive into section 1. To really wrap our heads around the innovation behind modularity, we're going to use this project as our hands-on case study.
So what is modularity anyway? At its core, it's a design philosophy. You're just taking a complex system and breaking it down into independent, interchangeable parts. The key idea is that each module does one thing and does it well. And you can tweak it, update it, fix it, even replace it entirely without breaking everything else. That's what gives you agility and the ability to continuously evolve.
Okay, enough with the theory. Let's get to the architecture. This is where we look at the actual project files and see how this idea of separating components plays out in the real world.
And right here, you can see modularity in action, just by looking at the project's file structure. You've got the core logic, the mining component, the smart contracts. Each major function has its own dedicated files. Miner.py handles mining, contract executor v2.py handles execution. This isn't just about keeping things neat and tidy. It's a fundamental design choice that lets each piece of the puzzle evolve on its own schedule.
Now we get to the heart of the system, the database. This is where the ledger, that immutable record of everything, is actually stored. This is the foundational layer that guarantees the integrity and permanence of the entire network. Peeking inside that database, we can see the anatomy of every single block. You've got the block ID, a timestamp, its own unique hash, and of course the most critical field, the previous hash. We also see the Merkle root, which is basically a cryptographic fingerprint that proves that none of the transactions inside that block have been tampered with.
And this right here, this is the magic. The previous hash of block 2, which is highlighted here, is the exact hash of block 1. That's it. That is the chain in blockchain in its purest form. Every block is cryptographically chained to the one before it. If you try to change anything in an old block, that chain instantly snaps for everyone to see. That's what makes it immutable.
So with the database in place, we need an engine to actually add new blocks to it. Welcome to the engine room, the mining layer. This is what's responsible for creating and validating new blocks, keeping the network alive and secure.
The mining process here follows a classic proof-of-work loop. First, the miner grabs pending transactions from the pool. Then it builds a new block. And then comes the heavy lifting. It has to start guessing a random number, the nonce, over and over again until it solves a cryptographic puzzle. The first one to find the solution gets to validate the block, add it to the chain, and collect the reward.
And what's the puzzle the miners are trying to solve? Well, in this project, the difficulty is initially set to 5. What that means is the final hash of the winning block must start with 5 leading zeros. It's a constantly adjusting target that keeps the network secure and block times consistent.
All right, section 5, smart contracts. So if the database is the heart and mining is the engine room, then smart contracts are the brain. This is where programmable logic and on-chain intelligence really come to life.
And this brings us to one of the most brilliant ideas in this entire architecture. Look at this. The smart contract code itself isn't hardwired into the blockchain's core. Instead, it's just stored as plain text in a database table. Think about that for a second. The contract is treated not as code, but as data. This separation is what makes the whole thing so incredibly flexible.
So, if the contract is just data, what actually runs it? That's where the engine comes in, a completely separate script. This contract executor v2.py file has one job: fetch the code from the database and execute it. The result is a beautifully decoupled architecture. You can upgrade the execution engine without touching a single deployed contract. That is just unbelievably powerful.
So we've looked at all the individual pieces. Now let's put it all together and look at the big picture. Why is this modular architecture such an innovative design, and what's the real value add here?
The benefits of this approach are just huge. You want to swap out proof of work for proof of stake? No problem, just replace the mining module. The rest stays the same. Need to scale up contract execution performance? You can optimize that layer independently. Updates become way simpler without needing complex and risky hard forks. And maybe most importantly, innovation can happen so much faster because different teams can specialize and push the boundaries on each module separately.
But, and this is super important, let's keep our feet on the ground. The developers themselves leave a very clear warning in their documentation. Using the exec function like this is insecure for a live production system. Now that's not a flaw. It's a sign of transparency and maturity. It shows that this is a proof of concept designed to explore ideas, not a finished product, and they're being upfront about it.
And that brings us right back to our original question. Are we looking at the future of blockchain technology? A project like this gives us a fascinating glimpse into a future where blockchains are no longer rigid monoliths, but are living, adaptable ecosystems, built piece by piece. The future might not be carved in stone, it might be assembled with Legos. Thanks for joining this explainer.